Hey everyone, Geophysicist Stefan Burns here. NASA has released all their images that they've collected of 3i Atlas over the past couple months, including their Mars Reconnaissance Orbiter high-rise imagery, which we see right here. They did this via a live stream. I also rebroadcast that live stream with some commentary from myself and also a post section where we kind of go through a breakdown. If you want to watch that, it's on my channel page. Click the live tab. But this is the best image that they have collected of 3i Atlas across all their different telescopes and satellites and probes in space. Billions and billions of dollars worth of equipment. Now, to be fair, a lot of this equipment is specifically designed to look at other things. So for example, the orbiters around Mars are studying Mars. And you also have, for example, the Parker Solar Probe, which is studying the sun. But they repurpose them to track 3i Atlas during its close approach to the sun and its time in the inner solar system. But this is the best image that we have of 3i Atlas, according to them, and what they were able to collect. We are also going to do a comparison to some amateur astronomer photos that have been collected over the past week or two. Here is 3i Atlas via the James Webb Space Telescope taken on August 6th, and you see, well, a bunch of pixels. This is meant for deep sky imaging, but supposedly this is the highest resolution, best telescope ever created. And well, we don't really see anything all that great with 3i Atlas as it relates to that. And here we have our Hubble imagery, which was taken on July 21st. And so this is when it's further away from the sun pretty quickly after we discovered it on July 1st. And we see it fairly nicely, but again, it's pretty blurry and grainy. And well, they say that this imagery here from the Mars Reconnaissance Orbiter and its high-rise camera is the best of the lot. This was taken on October 2nd. We see a clear sunward facing tail right there, or at least the coma is expanded a little bit out in the sunward direction. And there's some discrepancy between the different images that they were able to collect of 3i Atlas during this time frame, going from October when it passed by Mars through its perihelion October 29th, because some of them show this sunward facing tail, others show an anti-sunward facing tail. So we're going to look through the imagery that NASA released, specifically the high-rise imagery, and then also MAVEN and Lucy and a couple others, punch data, and then we're going to compare that to amateur astronomer data, because those images collected by amateur astronomers, that was done with, like, let's say a $5,000 telescope or a $10,000 telescope, or maybe if they're really serious, like $30,000 of equipment, whereas what we got from NASA cost the US taxpayers billions and billions of dollars. Here we have the same imagery of 3i Atlas taken by the Mars Reconnaissance Orbiter on October 2nd, but this time we have our scale bar and also the trajectory of the comet. Remember, the comet's flying in effectively towards the sun at this time, October 2nd. So this is showing that the coma or the tail is pushing more towards the sun, at least according to this imagery. And people were very excited about this image, even though it took months to release, because we were supposedly going to get the highest resolution look at 3i Atlas, and we're able to confine the size of its nucleus using this image and the brightest pixel, which I have marked out there with this red dot. So we did analysis on the live stream. We found that brightest pixel, and well, at least with what we did, it's that red dot right there. That's about 20 kilometers across. One pixel is 20 kilometers roughly in this image, and that's about 12.42 miles. So it looks like we're mostly seeing the coma here, and that all the dust and gas and plasma of the coma is obscuring our view of the nucleus. The estimate for the size of 3i Atlas given by NASA during the live stream was 1,400 feet across to 3.5 miles across. So that is their official size estimate. Some of the size estimates are much larger than that from other scientists and groups. One of them is even up to like 50 kilometers across, but NASA is saying that it's maximum 3.5 miles across, and that it's not super oblong or irregular in shape. So this high-rise imagery tells us something, but it really doesn't tell us all that much. It honestly just looks like a street lamp on a foggy day in England. So this is their best image with billions of dollars spent and all that equipment in space and staff and everything, servers and more. This is the best that we were able to get for that effort. Now here we're looking at imagery of 3i Atlas taken by MAVEN, which is another probe that's orbiting around Mars. And this is interesting because MAVEN specifically looks at ultraviolet light. So here we see our scale bar. This is 100,000 miles across at the comet, though we are looking at this from about 35 million miles away. And that's the distance that all the Mars-based observations basically were looking at the comet. Specifically for October 2nd with the high-rise imagery, that was from 30 million kilometers away, or about 20 million miles away, or 0.2 astronomical units. So the fact that this October 9th, the comet or interstellar object, 3i Atlas, whatever you want to call it, it was getting closer to the sun. It moved a little bit further away. We see that bright pixel there, that is representative of about 33,000 miles. So because this is so low resolution here, that is 33,000 miles across based off of the size that they provided with this scale bar there. So that is very clearly the coma shining very brightly in ultraviolet light. And then you have outside of that, this hydrogen emission, because there's also a whole bunch of elements like hydrogen, and you have water, CO2, right? They're all kind of effervescing, you could say. And so the hydrogen shows up clearly there, though at a lower density. And that bright pixel represents the majority of like the highest density coma of this comet or interstellar object, which is comprised of gas, dust, and plasma. That's the interesting thing. I've said this many times on the channel. I'll continue to say it. You will notice, if you pay attention, that no one in the mainstream, even those that are talking about the alien angle, technology, whatever, they will not talk about plasma, okay? Why is that? When the moment you have dust and gas in space, you have plasma because you have the ionization of the sun, that's photoionization. You also have charge transfer ionization from the solar wind particles, and you have electron ionization because you have these already energetic electrons in the area that can also then knock off more electrons. So dust grains take on a positive or a negative charge. It depends on a lot of factors. And you also then, as a result of having plasma, have magnetic fields, you have electric fields, and no one in the mainstream, doesn't matter if they're like, this is a comet, this is an alien ship, whatever, none of them are mentioning plasma. But here we're looking at ultraviolet emission, which comes from plasma. We have to keep in mind that 3i Atlas, whatever it is, it clearly has a lot of plasma surrounding it. And in fact, the sun just launched a coronal mass ejection towards 3i Atlas, and that's expected to hit on the 22nd of October around 12 noon Universal Time. So it'll be interesting to see if there's perhaps a tail disconnection event from 3i Atlas at that time, because amateur astronomers are picking up now multiple jets emanating from 3i Atlas and also a tail. But with this initial imagery taken back early October that NASA's just now released, we don't really see any observations of a tail all that clearly, though we do see a little bit with punch data. So let's check it out. Here we have a composite image of 3i Atlas taken by NASA's PUNCH, which is a fleet of satellites that are observing the sun and heliospheric environment. And all these images were taken from September through October. Here we see 3i Atlas, and we see this very short stubby tail. It's going this direction in the video that they've given, which we're going to go to in a second. But we do see this very tiny tail there. So it's interesting that some of the images that they provided show a sunward facing push of the coma or tail, and then others show something going the other direction, anti-sunward facing. Here we see the video provided. So we can see 3i Atlas here, and you'll actually will notice Mars swing through. So they mentioned that this white blob that appears is actually the planet Mars, because of course 3i Atlas did a close approach to Mars on October 3rd. And if we look specifically at our photo of that, which I find interesting, here's 3i Atlas, there's Mars. Mars shows up really pixelated and grainy, whereas 3i Atlas shows up very, very nice. Now, they were specifically stacking frames and composites of 3i Atlas to pull out the details. That's probably one reason why Mars isn't showing up well, but Mars is a freaking planet. And it's also very close, just like 3i Atlas is, to the Punch fleet of satellites. So why doesn't it show up in better detail, or at least bigger and brighter? I can't really say. And I can't really comment on this too much other than I find it a little odd that Mars looks the way it does here, whereas 3i Atlas is like sharper, more defined, and basically the same size, glowing as brightly. But we know that the apparent magnitude of Mars is much, much, much brighter than 3i Atlas at this time. So that's kind of odd. But this Punch data is one of the other images that have been released from NASA. And in fact, I'll put a link to their image gallery in the video description if you want to check these out yourself. And here we have an image of 3i Atlas taken by the Lucy spacecraft from 240 million miles away on September 16th. And it's circled with this red dot. There is 3i Atlas, and we see this smudge there. This is going to the right. The solar system north is up, which means that this is going towards the sun. So here we see this sunward facing tail and or coma, whereas again we saw with other spacecraft this anti-sunward facing tail around this moment in time. So a lot of abnormalities just based off of that, and there are a lot of other abnormalities as it relates to this unusual interstellar object. NASA was very clear the entire live stream. They came right out of the gate with it. You can watch it if you want on their channel or mine, about how it's a comet, and just attack that conspiracy angle right away. I wouldn't even say it's a conspiracy angle unless you go into the alien or technology side. It's just, can we even call this thing a comet if it's not from our solar system? I mean, why can't we open up the dictionary book? They delisted Pluto as a planet because, well, it wasn't big enough to be a planet. They opened up the dictionary book and put in new entries, and now it's a dwarf planet. Yet anything that is showing behavior that's just zooming through the solar system really quick basically has to be a comet. I don't know why we don't have different definitions of things other than just one bucket for a comet, but that's a different story. This is the Lucy imagery, and again, it's really not that spectacular. None of the imagery that we've been getting of 3i Atlas from NASA has been spectacular, but some amateur astronomers have been doing incredible work, and with much less expensive equipment. We're talking thousands or tens of thousands of dollars rather than billions of dollars. Let's give their imagery a look. So here we have our first image of Interstellar Object 3i Atlas taken on the 8th of November, so fairly recently. And this was one of the first good images that we received of 3i Atlas post-perihelion, its closest approach to the sun, which was October 29th. It was definitely still in the glare of the sun at that time, but pretty quickly actually moved out of the glare of the sun thanks to its high velocity. And well, here we see 3i Atlas, and we also see its tail anti-sunward facing, and these jets emanating off it, in addition to a sunward facing jet. So again, think gas, dust, plasma. And keep in mind here, this tail is kind of foreshortened with our view because it's still at an angle where it's mostly stretching out behind 3i Atlas rather than out to the side for our viewing ability. So that's November 8th right there. Here we also November 8th. This is a more punched in view. And by the way, all the links to these astronomers and the original credit is linked in the video description. So here they identified the 5 different jets, 1, 2, 3, 4, 5. And we see the sunward direction there. This is November 8th, our view of 3i Atlas from Earth with just normal astronomical equipment that costs maybe thousands or tens of thousands of dollars. Here we have the 9th of November, 2 different views, the optical, then also a black and white. We see that because it's moved a little bit further, we get a better view of the tail, and the tail is undergoing some changes due to the rotation of 3i Atlas, which is about 16 hours to do kind of a tumble, and also because it's moving further away. And the solar wind also affects the tail of comets or things like this if they start to off gas and it becomes ionized and more. Here we see imagery from the 10th of November. Same deal. We see a very faint tail here, but we see these jets a bit more clearly, very wide diffuse coma, and that sunward facing jet is very clear with this imagery here. And then we have our next image here. This is the one that's really been making the rounds. Maybe some touch up was done to this, it's hard to say, but it doesn't appear that there was really any like artificial touch-up done. This was taken on the 16th, and we see a very clear coma around 3i Atlas. This is probably the best image that we got. It is accurate in terms of sky position. We have this galaxy cluster there, and we see the tail. We also see these other jets. You see the consistency across time from these different amateur astronomers with their photos, which tells you something. So it's additionally odd that the biggest space agency in the world isn't showing consistency with their images, whereas these amateur astronomers from Earth with much cheaper gear are. And then here's our latest image of 3i Atlas that I could find for today, the 19th, taken in the morning. As far as I could tell, our optical image there. Looks like a little bit of color enhancement done on that, and then our black and white there. So different grades of quality to these, but you can see that there is a consistency across time with them, and I would argue that they're quite a bit better than that high-rise imagery that was collected of 3i Atlas, because that was honestly, well, kind of embarrassing. To have a whole live stream for that, I thought was really quite silly. I mean, this, yeah, the pixel density is quite high, but this basically doesn't tell us anything. It's a blurry, fuzzy blob. And I'm not sure what they expected, and the public response thus far has been not good. Let's just say that. But I'll keep you up to date with what is happening as it relates to 3i Atlas. That is your short video with some of the imagery released from the NASA live stream. You can check out my full commentary on that live stream, plus the post credits. I'll link that in the video description below, and I'll also link the NASA image gallery in the video description below. You can make up your own mind as to all this if you want. That's what I recommend you do. Do your own research. That's what I do myself, and I present these videos to you. I don't think it's a comet. I also don't think it's aliens or technology. I think we're looking more here at a very unusual thing flying through the solar system of interstellar origin that definitely has a very rich plasma environment to it, and maybe it's even a plasma biont, if you know what that is. There's a lot of discussion as to plasma-based organisms. So that is kind of what I've been talking about from the beginning here on the channel, and I'll keep you up to date on all that and much more. So thank you all for watching. I've been your host, Stefan Burns, wishing each and every single one of you well. Please take care of yourselves, and I'll see you all in the next video.